Hey guys, today for math we're going to be working on inscribed hexagons. Here's some of your learning targets. I can use a compass to draw a circle. I can inscribe a hexagon within a circle. I can draw regular hexagons. The cool thing about hexagons is they're all over the place, and you may or might not know this actually, but in real life we know that bees make honeycomb that have hexagonal shapes. If you ever catch a snowflake and they have a dendritic shape to them, ooh, there's a fancy word for you. Sometimes they're in the shape of a hexagon, 6 sides. Those of you that play soccer, yup, the soccer balls have 6 side shapes on them. In different arts across the world, there can be art designs with 6-sided shapes. And if you know someone that quilts, we have a lot of quilt designs that come in 6-sided shapes or hexagon as well too. So hexagons are everywhere, and you're going to get some practice in math actually drawing, inscribing regular hexagons. So let's ask ourselves first, what does inscribed actually mean? Or maybe we just need a refresher on what it means. So if you take apart the word inscribed and look at the word scribe, scribe is actually Latin, and it means to write. So if you think about it, inscribed means to write in something. So in this case, in math, an inscribed polygon is a polygon whose vertices are all on the same circle. Here we have a 1, 2, 3, 4, 5, 6-sided shape, so a hexagon, and the vertices all lie on the circle. Same with our equilateral triangle over here. Here's a vertice, a vertice, a vertice. They all lie on the circle. And the sides are going to be the same length, so that makes it a regular polygon. Speaking of that, let's do a quick vocabulary check-in. A hexagon, which you'll be working with today, is a polygon with 6 sides or 6 angles. A regular polygon means all the sides and angles of the polygon are the same. So all of the sides measure the same, all of the angles measure the same. A circle is a geometric figure with points the same distance to the center of the circle. Radius, the distance from the center of the circle to a point on the circle. You can also think of a radius as a line segment. And a compass is a tool that we use to draw circles. All right, time for another cool video. Here we go.
What we're going to do in the next few videos is construct regular figures inside of circles. So we're going to start out with a circle. So I'm going to move my straight edge out of the way here, and I'm going to make a point, and I will call it C, and C is going to be the center of our circle. So let's review how we make a very nice circle with a compass. So you want to set your pin in the point that's going to be the center, and hold your compass off at an angle like this. And remember, the easiest way to do it is actually to spin your paper and just let your hand hold the compass still. Now that is a beautiful circle centered at C. The first geometric figure that we want to construct inside of our circle is a regular hexagon. So regular hexagon. Regular, so it'll have all the same side lengths, all the same interior angles. Hexagon, meaning it will have 6 sides. Regular hexagon is fairly easy to construct. First thing you want to do is draw a line or line segment that is going to intersect your circle twice, once over here and once over here, and also goes directly through the center of your circle, that point C, where we started from. And we can go ahead and mark our intersection points. Once you've done that, you're going to keep your compass at the exact same radius, so what you used right here to measure, to start drawing your circle, I should say. And you're going to move it over though so that the pin of your compass, instead of starting in the center now, is over here on the edge. And you're going to stick your pin in there. You're going to swing an arc so it intersects here, and then it intersects over here. Keep moving, keeping the same length. You're going to put your pin here at that intersection, swing another arc. Once you get to here, you can see that this length goes right over this intersection here to that point is the exact same length as this. And we want that. That's your check as you're going around to make sure that your compass, I know a lot of these compasses will, you put a little pressure on them and they change sizes fairly easy. Well, this is a good place to check and make sure that your compass hasn't changed size. So if you go here, here, and then on your third one you're trying to draw, you intersect that point perfectly, you're set. So you keep going, put another one over here, alright, and then we can make that same check here. So that length looks great. Once you have all these intersection points, you can go ahead and make them a little more distinct if you like so. And you're going to take your straight edge and go ahead and just make some segments connecting all those dots. So a segment there, a segment there, segment all the way around. You want to take your time with this. I'm going a little fast. I'm not being super precise, but you want to make sure that you are. Make your hexagon look very nice. And one last one to there. And there you have it. We have a regular hexagon. A six-sided figure. All those side lengths are exactly the same, and all those interior angles are the same.